You put food in. You press a button. 2 minutes later, it's hot.
But how? There's no fire, no flame, no heated surface. The air inside isn't even hot. So what on earth is actually heating your food? The answer involves World War II radar, the physics of spinning molecules, and a discovery made completely by accident. Let's go.
It's 1945. World War II is ending. An American engineer named Percy Spencer is working on radar technology, specifically a device called a magnetron that generates microwave radiation. One day, while standing near an active magnetron, Spencer reached into his pocket and found his chocolate bar had melted. Not from heat, not from touching anything hot. It just melted. Spencer was curious. He grabbed a bag of popcorn kernels and held it near the magnetron. They popped. He tried an egg next. It exploded in a colleague's face. Within 2 years, Raytheon built the first commercial microwave. It was 6 feet tall, weighed 750 pounds, and cost $5,000. Today, you can get one for $60. But we still haven't answered the real question. What is actually happening inside that box when you heat your food?
First, what even is a microwave? It's not heat, it's not sound. It's electromagnetic radiation, the same family as radio waves, visible light, and X-rays.
Microwaves have a wavelength of about 12 centimeters, roughly the size of your hand. That's why they're called microwaves. They're much shorter than regular radio waves. Still invisible, though. Inside every microwave is a device called a magnetron. It takes electrical energy and converts it into microwave radiation. Electrons spiral around inside it at incredible speed, generating the waves.
The microwaves shoot into the metal cooking chamber. Metal reflects microwaves perfectly, like a mirror for these waves. They bounce around inside, filling the space evenly. And then the waves hit your food. This is where the real magic happens, at the molecular level.
Water. The water molecule has a positive side and a negative side. It's called a polar molecule or electric dipole. One end is slightly positive, the other is slightly negative. When you place a water molecule in an electric field, it rotates to align with the field. Positive toward negative, negative toward positive. It's like a compass needle following a magnet.
Now, microwaves switch their electric field direction 2.45 billion times per second. The water molecule tries to follow. It spins and vibrates at 2.45 billion rotations per second. That spinning is heat. And your food has millions of these water molecules, all spinning simultaneously, all generating heat. That's why microwave heating happens from the inside out, not from a hot surface.
In a conventional oven, heat travels from the outside surface inward. It takes time. The outside can burn before the inside is cooked. In a microwave, the waves penetrate directly into the food and heat it throughout simultaneously. That's why leftovers heat in 2 minutes instead of 20.
Now, the question everyone has asked at least once: why does metal spark in a microwave? And is it actually dangerous? Metal is full of free electrons, electrons that can move around. When microwaves hit metal, they push these electrons around rapidly. The electrons rush to the edges and tips of the metal object. The charge builds up so intensely at the sharp points that it ionizes the air, rips electrons off air molecules. This creates a tiny plasma arc. That's the spark. Thin or crumpled metal like aluminum foil is the most dangerous because it has more sharp edges. A smooth, heavy spoon is less likely to spark, but still not worth the risk. And those tiny holes in the microwave door? They're smaller than the 12-centimeter wavelength of the microwaves, so the waves can't escape. You're safe to look through it. Here's something everyone experiences. Your microwave food is burning hot at the edges and freezing cold in the center. Why? Isn't it supposed to heat evenly? Microwaves inside the oven create a standing wave pattern, like waves in a bathtub that bounce and interfere with each other. Some spots get double the energy, hot spots. Some get almost none, cold spots.
That's why the turntable exists. It rotates your food through the hot and cold spots so it heats much evenly. Some modern microwaves use a rotating antenna instead. Same idea. Why does your coffee get boiling hot but the mug handle stays cool? Because the ceramic has almost no water molecules. Microwaves barely affect it. The coffee is almost entirely water. It heats instantly.
If you put a grape cut almost in half with just a thin skin connecting the two halves in a microwave, you get a plasma fireball.
Your microwave operates at 2.45 gigahertz. Your Wi-Fi router also 2.4 gigahertz. They're competing for the same frequency. When your microwave is running, it can actually slow down or disrupt your Wi-Fi signal. That's why your video call stutters when someone heats leftovers. Microwaves only penetrate about 2.5 centimeters into your food. Below that depth, regular heat conduction takes over, which is why thick food still needs time to heat through. That's why letting food rest for 2 minutes after microwaving actually helps. The heat from the outer layers conducts inward.
Microwave safe means the container itself won't heat up dangerously or leach chemicals. It doesn't mean the food won't get scalding hot. Older plastics, especially types 3, 6, and 7, can leach chemicals into food when microwaved. When in doubt, use glass.
Percy Spencer patented the microwave oven in 1945. Raytheon made billions. Spencer himself received no royalties, just a $2 award from the company. By the year 2000, over 90% of American homes had a microwave, one of the fastest adoptions of any home appliance in history.
The International Space Station has no microwave oven. Why? Because in zero gravity, convection doesn't work properly, and a standard turntable is pointless. NASA is actually developing a modified microwave for future deep space missions. No turntable, the waves are distributed differently.
So here's the full chain. World War II radar led to the magnetron. The magnetron generates microwaves. Microwaves spin water molecules 2.45 billion times a second. Spinning molecules generate heat. Your soup is hot. Next time you press start on your microwave, remember, you're using a spin-off of World War II radar technology. Next episode, Wi-Fi. How does an invisible wave carry a Netflix movie through a concrete wall into your phone? The physics is actually wild. Subscribe so you don't miss it.